Today we're going to look at step functions. So a step function is a special case for a piecewise function. So a step function or staircase function is a piecewise function containing all constant or pieces. The constant pieces are observed across the adjacent intervals of the function as they change value from one interval to the next. A step function is discontinuous, which means it is not continuous. So you cannot draw a step function without removing your pencil from the paper. This is an example of a step function, and this particular graph comes from this step function. These are basically your rules. So there's three functions here, or three pieces to this piecewise function. Just remember that f of x is the same thing as saying y equals. So you have a function y equals -3 when the interval is from x is less than -2. So keep in mind this would be an open circle, and it would be y is -2 for everything to the left of -2. So for instance, this part of the piecewise would be that graph. So from -2 and all the numbers less than, you would have y equal to -3. Just remember that any y equals a number is always a horizontal piece. So like y equals 3 would be a horizontal line at 3. The next piece is y equals 0. And that is over the interval -2 to 1. So if you look, you're going to have a closed circle at -2 because the symbol is less than or equal to. You're going to have a closed circle at 1 because it's less than or equal to. So that would represent this interval in the graph, as I highlighted in the orange. Notice it starts at -2 with a closed circle and stops at 1 with a closed circle. That's the orange interval. And then the last piece of this piecewise step function is y is equal to 3, and that is when x is greater than 1. So since we have x is greater than 1, we're looking at an open circle at 1, shaded to the right, or making a horizontal piece to the right. Because these intervals are open-ended here, so this goes all the way to -infinity, and this one goes all the way to infinity, we have the arrows on each end. No arrows here because that interval was restricted. So just some things to talk about, some of the features of step functions. You are going to utilize open circle and closed circles on the graph. Open means the point is not on the graph, and closed means the point is on the graph. So for instance, if we were looking at this, we have an open circle and a closed circle. So you're going to be able to see if, perhaps if you analyze it to see if it's a function, if I drew a vertical line at 1, it would go through the hole in the graph here. So technically this would only hit the function one time. It would hit where the closed circle is. So this is actually a function because every vertical line you draw, so it would pass the vertical line test. It can get confusing with the open circles, but just keep in mind that an open circle does not include that value. You're also going to have horizontal pieces, horizontal meaning left to right. This is why they call it a step function, because it resembles steps. We talked about it being discontinuous, meaning that these are not connected, so we have no line running from each piece, so they're actually broken. So it's one, and then you pick up your pen or pencil, draw your next one, pick it up, draw your next one. They're not connected. They're not a continuous function. It says, notice the resemblance to a set of steps, and it may or may not be a function. We check with the vertical line test. So we said this example is a function. So now let's look at how to graph these. So first we're going to look at example 1. Example 1 has a piecewise function, and we have 3 defined intervals. Now just remember, f of x is the same thing as y equals. So for the first interval here, right here, that is the interval y equals 4. So basically your rule is y equals 4. And you're going to create an xy-t table, and you're going to use the interval from 0 to 2. So from 0 would be 0, 1, 2. And then remember, with horizontal lines, if y is equal to 4, all your values of y will be 4. Something to keep in mind, this would be a closed circle at 0, so I'm going to put right next to it a closed circle. So when I graph it, I know to put a closed circle. And at 2, we're going to have an open circle. And then you're going to have some horizontal line in between. I know this looks like a vertical line, but it's just the way our table is listed. So let's graph this interval. So we have at 0, 4, a closed circle. At 1, 4, a closed circle. And then at 2, 4, we have an open circle. So we're going to draw our step with a horizontal line right there. Notice the interval does not continue, so there are no arrows. It's only graphed from 0 to 2. Our next piece is y equals 5. Okay, so when y equals 5, we're going to look at the interval from 2 to 4. So I'm going to create an x, y, t table when x is from 2 all the way to 4. So 2, 3, 4. And remember, with horizontal lines, if y equals 5, all the values of y will be 5. We'll focus here on the fact that this is going to be a closed circle at 2 and an open circle at 4. And then you would have the line in between. So let's graph this interval. 2, 5 would be a closed circle. 3, 5 would also be closed. And 4, 5 would be open. Make sure that whoever's grading can determine the difference between your open circles and your closed circles. So you could see from my picture, open, these are definitely open, and that is definitely closed. And then our last piece here is y equals 6. That's the orange. So I'm going to take the equation y equals 6. I'm going to graph that over the interval from 4 to 6. So that will include 4, 5, 6. Remember, if y is 6, all your y's are 6. We're going to have a closed circle and an open circle. And it'll be shaded in between. So 4, 6 will be here, closed circle. 5, 6 is also a closed circle. And 6, 6 is an open circle. Okay, so there would be your step function. So just to kind of review, right? This part here was the yellow. That's your first interval, and that was this that I graphed. And then your second interval was y equals 5. That was this one. Okay, and that was the second interval I graphed. And then the last one, which was the orange, was y equals 6. That was this piece here, and that was this last interval. And notice that they're not connected in between. There's just 3 steps. They don't have to be the same distance, or they don't have to be the same distance in between, but this particular problem just has it that way. Let's look at example 2. Example 2 has s of x, which we know is the same thing as y equals. So we have y equals 3, we have y equals 1, and we have y equals 2. Those are the 3 functions. And we're going to take those equations and use the intervals that were given. So for y equals 3, we're going to go from -5 to -2. So -5, -4, -3, -2. And our corresponding y's will all be 3. Let's look at the circle. We have a closed circle at -5, open at -2. So closed, open, we'll shade in between. Okay, for y equals 1, we're going to look at -2 to 3. So you can either graph the intervals in between or create all your tables and then graph. So I'm doing this one slightly different. Here I did each one and graph. It's whatever you prefer. Here I'm going to do all the tables and then I'll graph. So this has to go from -2 all the way to 3. -1, 0, 1, 2, 3. And all your corresponding y's will be 1. Because after all, y equals 1. We're going to have a closed circle at -2. An open circle at 3. And we'll shade in between. Draw a line in between, I should say. For y equals 2, we're going to use the interval from 3 to 5. So we have 3, 4, 5. Your y's are corresponding to. And then we have closed circle, closed circle. Okay. So now we're going to graph our piecewise, or our step function. -5, 3. 1, 2, 3, 4, 5. -5, 3 would be closed. Now you don't necessarily have to graph all these points. You can graph the closed circle and the open, and you know that it's a horizontal line in between. So -2, 3 would be open, and then you're going to put your line in between. You don't have to graph each individual point, especially for a step function. You know it's a horizontal line. For here, for the second one, we have y equals 1. We're going to start at -2, 1, and that's going to be a closed circle. And then we're going to end at 3, 1, and that's going to be open. There's the second parts of the piecewise. And then the last part, 3, 2, is going to be closed. And we're going to go to 5, 2. Notice for this one, the intervals aren't the same. This was 3 boxes, this was 5, this was 2. Also, we had some closed circles here, and open and close. Now, if you were to check to see if this was a function, every vertical line you draw will only cross once. So right here, it would go through the hole, so that doesn't count, and that would cross once. All of these would cross once. Same thing here, it would hit, and then it would not cross here. So this technically is a function, so that's a step function. So we graphed each individual piece, and then your step function is complete.